Have you ever wondered what would happen if you fell into a black hole? Imagine drifting through the silence of space, surrounded by billions of stars, when suddenly you encounter something invisible. There are no flashing warning signs, no giant cosmic monster waiting in the darkness. Yet hidden before you is one of the most powerful objects in the universe. An object with gravity so strong that nothing can escape its grasp. Not planets, not stars, not even light itself. This mysterious object is known as a black hole. For decades, black holes have captured the imagination of scientists, astronomers, and dreamers alike. They challenge everything we think we know about space, time, gravity, and even reality itself. But what exactly are black holes? How do they form? Why are they so powerful? And what secrets might be hiding beyond their mysterious boundaries? To answer these questions, we need to travel deep into the universe and witness the death of a giant star. Every star in the universe is engaged in a constant battle. On one side is gravity, pulling everything inward. On the other side is the immense energy produced inside the star's core, pushing outward. For millions, and sometimes billions of years, these forces remain balanced. This balance allows stars to shine brightly across the cosmos. But eventually, every star runs out of fuel. For stars similar to our sun, the ending is relatively peaceful. However, for stars many times larger than our sun, the ending is far more dramatic. As the fuel begins to disappear, the outward pressure weakens. Gravity suddenly gains the upper hand. The star begins collapsing inward under its own enormous weight. The collapse happens faster and faster. Temperatures rise to extraordinary levels. Pressure becomes unimaginable. Then, in a violent explosion known as a supernova, the outer layers of the star are blasted into space. What remains behind is a collapsed core. If that core is massive enough, gravity compresses it into an incredibly tiny region. A region so dense and so powerful that it creates a black hole. To understand just how extreme this is, imagine compressing an entire mountain into something smaller than a grain of sand. Now, imagine compressing the mass of a giant star into a space far smaller than a city. The result is gravity, unlike anything we experience on Earth. A gravity so powerful that once something gets too close, escape becomes impossible. Even light cannot break free. And because light cannot escape, black holes appear completely dark. This is why they are called black holes. But if black holes are invisible, how do scientists know they exist? The answer lies in their effects on the surrounding universe. Although we cannot see a black hole directly, we can observe how nearby stars behave. Scientists often discover stars orbiting around something invisible. They observe gas and dust spinning at incredible speeds around empty regions of space. They watch light bending in strange ways as it passes through powerful gravitational fields. It's as though the universe itself reveals the presence of something hidden, something powerful, something waiting in the darkness. In 2019, scientists achieved something many thought impossible. Using a network of radio telescopes spread across Earth, they captured the first image ever taken of a black hole. The image showed a glowing ring of superheated gas surrounding a dark central shadow. for the first time in human history, we were able to glimpse one of the universe's greatest mysteries. Surrounding every black hole is an invisible boundary known as the event horizon. The event horizon is often described as the point of no return. As long as you remain outside this boundary, escape is still possible. Cross it, and everything changes. No spacecraft can return. No signal can escape. No message can ever be sent back. Beyond the event horizon, all paths lead inward. And that brings us to one of the most fascinating questions in science. What would happen if a human being fell into a black hole? The answer is more terrifying than most people can imagine. Imagine slowly drifting toward a black hole. At first, the experience might seem surprisingly normal. If the black hole were large enough, you might not immediately notice anything unusual. The stars would still shine around you. Space would appear calm. But as you drift closer, gravity would begin to reveal its true power. The force pulling on your feet would become stronger than the force pulling on your head. Your body would begin stretching, slowly at first, then more dramatically. Scientists call this process spaghettification. Despite its humorous name, the reality would be terrifying. The increasing gravitational forces would stretch you into a long, thin stream of matter. Eventually, every atom in your body would be pulled apart. According to our current understanding of physics, survival would be impossible. Yet this is only the beginning of the mystery, because beyond the event horizon lies something even stranger. At the center of a black hole is a region known as the singularity. A singularity is believed to be a point where matter is compressed into an infinitely small space. Here, gravity becomes infinitely strong. The equations that scientists use to describe the universe begin to break down. Space and time themselves may lose their meaning. And this is where our understanding reaches its limit. We know black holes exist. We know how they form. We know how gravity behaves around them. But what truly happens inside remains unknown. Some theories suggest that black holes may connect distant regions of the universe. Others propose that they could be linked to wormholes. Some physicists even speculate that black holes may contain clues to entirely new laws of nature. At this point, nobody knows for certain. And that uncertainty is exactly what makes black holes so fascinating. Many people believe black holes roam through space, swallowing everything in sight. Movies often portray them as cosmic vacuum cleaners capable of devouring entire galaxies. But reality is much different. Black holes only affect objects that come close enough to their gravitational pull. In fact, if our sun were magically replaced by a black hole with exactly the same mass, Earth would continue orbiting almost exactly as it does today. The planet would not suddenly be pulled into darkness. The real problem would be the loss of sunlight and heat. Life on Earth would disappear. But gravity itself would remain nearly unchanged. The universe contains black holes far larger than anything formed by dying stars. These giants are known as supermassive black holes. Some contain millions or even billions of times the mass of our sun. Scientists believe that nearly every large galaxy contains one at its center, including our own Milky Way. At the center of our galaxy lies Sagittarius A star, a supermassive black hole located about 26,000 light-years away from Earth. invisible, silent, yet powerful enough to influence the motion of countless stars. The more scientists learn about black holes, the more questions emerge. They challenge our understanding of physics. They challenge our understanding of reality. And they remind us that the universe is still filled with mysteries waiting to be solved. Perhaps one day humanity will unlock the secrets hidden beyond the event horizon. Perhaps one day we will understand what truly lies at the center of a black hole. But until that day arrives, black holes remain one of the greatest mysteries ever discovered. A reminder that even in our age of technology and exploration, the universe still holds secrets beyond our imagination. And somewhere, in the endless darkness of space, a black hole waits, silent, invisible, mysterious, and watching. You've been watching Global Decode, where curiosity meets discovery.